Hi everyone, welcome to the EViews demonstration. So I'm actually going to work on the assumption that all of you have used EViews in Econometrics 3. Most universities actually do that. You should have the basics of EViews from year 3. And so I'm going to work on the assumptions that you already know how to import the data into EViews, and also the fact that you have already dealt with the different types of data and so forth. So this should not come as a shock. So what I did is I just came with an already prepared work file, which I'm also going to upload on um, Canva. All right. So although I have so many examples here, so many variables here. Now you should remember that we are using cross-sectional data, and you'll actually also see in the instruction paper that I'll also upload together with this that I'm basically looking at the data for 4 commercial banks and over a period of 2009 to 2018. So I'm actually looking at the relationship between bank stability and credit risk and liquidity risk and GDP. But for this particular demonstration, I'm just going to use two variables just to demonstrate certain things. So I'm actually going to look at how non-performing loans affect economic growth. Now, non-performing loans are loans that are actually bad up until loans that are no longer in use for up until 90 days. So we consider them as non-performing loans. Um, and then of course we are using GDP um, as a dependent variable, and now NPL as the independent variable. So now before I proceed, I just want to demonstrate one thing. Remember that in the lecture I did indicate that we are often required to convert our data into natural logarithm. Um, okay, and so if you are required to convert such data, so this is how you do it. You simply just use this open space here where you use your command, then you type GENR for generate, and then you indicate space. Then suppose we want to convert NPL into natural logarithm. So then what we do is we basically then type ln NPL space equal sign space log open brackets NPL. Then you press enter. So once you press enter, then it will actually then appear. So then you can convert all your variables into natural logarithm. All right. Now, what if we want to estimate the function that I spoke about earlier, where we are regressing NPL on GDP? So we simply click. We can either do it in two ways. You can either click on quick estimate equation, then you can type the variables here. You have to type the variables the way they appear here. Okay, so the way they appear here. So I'm actually going to use the non-logged data, but it doesn't matter. You can use even the log. As you can see, I've actually converted them into natural logarithm, except for GDP, because GDP has negative value, so I couldn't log it. Okay, all right, fine. So now if you want to estimate, if you want to, suppose we are interested in determining the effect of non-performing loans on economic growth. So we are going to type, we start with a dependent variable, GDP space C for constant space, then we type NPL, which is the independent variable. Okay, so once we do that, we click on OK. So once we click on OK, we have our output. So this is how our output looks like. It tells you what the dependent variable is, what the method is. Of course, it will show as if it will show panel, because panel and cross-sectional goes hand in hand. And here it shows you how many cross-sections or cross-sectional units are included. 4. Remember I spoke about 4 banks. And then it tells you the total panel, which is basically the number of observations, which is 156, because we're counting from 2009 quarter 1 to 2018 quarter 3. So then it gives you the coefficients, the constant and the coefficient of the um, independent variable. So this is the rate at which for example, the dependent variable changes as a result of a change in the independent variable. It gives you all the other statistics, the R square, the F statistics, the probability of the F statistics, the Durbin-Watson for autocorrelation. It gives you the probability values that will tell you whether or not the variable is significant or statistical significant or not. Also the T ratio, also whether the variables are statistical significant or not. All right, so you repeat the same exercise using the logged variables. Now, what if we want to estimate? What if we want to estimate the, the quadratic function? Before I go to that, I forgot that I said I need to show the two ways of estimating the equation. So you can either use that quick estimate equation and type in, or alternatively, you can just click the variable. So you start with your dependent variable, GDP, then your independent variable, NPL. So you click on one, and then you press Control so that you can select the other. Then you right click, and then you choose on open them as an equation. Okay, so once you open them as an equation, you can see this is the C that we have typed in the constant. So usually if you use that approach, the C is going to be outside, or as that it will appear as the last variable. I just like typing it between or immediately after the dependent variable so that you can then also easily identify the independent variable, but it doesn't really matter where it is. So if you click OK, then you can see. Now in this case, you can see again, it's just the same. It's just that with the previous method, NPL was down and C was up. Now in this case, they just changed the positions, but you can actually see that it is basically the same equation. All right. Now, what if we want to estimate, what if we want to get the descriptive statistics of these variables? Again, it's very easy. The good thing is that you just highlight them. It doesn't matter whichever order you highlight them. Then you right click, then you say open them as a group. So now once you open them as a group, then you click on view. Once you click on view, then you can click on descriptive statistics. If you want descriptive statistics, then you can choose the individual samples. Once you choose the individual samples, it will then give you the mean values for each variable, the median, the maximum, the minimum, the standard deviation, the Jacques-Berer test, which measures which tells you about the normality of the variables, and obviously you look at the probability value. For example, if you look at these two variables, it basically telling you, for example, GDP is not normally distributed because this probability value is not less than 5%. And if you look at NPL, it is actually normally distributed because it's actually less than 0.05%. So that is actually how you do the what you call the descriptives, how you derive or how you obtain the descriptive statistics. Okay, then from this again, we can also, what if, for example, we want, remember in the last slide, I spoke about forecasting. Now, suppose we want to forecast GDP. So what we do is, in order for us to do that forecasting, first of all, we will need to estimate the normal equation. So since we have already highlighted the variables, we just right click them, open as an equation, and then we click OK. So if we click OK, we get our output. Now, if we want to forecast GDP, all we have to do is just click here on forecast. Now, once you click on forecast, it will give you the name here, GDPF. F is for forecast. So you don't have to do anything. All you want to do is you just click on OK. Okay. Now, once you click on OK, what will happen is that that variable will automatically saved in your work file. You can actually see GDP forecast is here. So it will give you the graph and the blue one is the forecasted one. So what you do is then um, you basically just, if you want to see uh, the this so for example, now if you want to estimate the function using the dependent variable which you forecasted, so you can just then go on estimate. Then now you can just change here GDP to GDPF, then you click on OK, and then now it will give you the new output with a forecasted variable, forecasted dependent variable, and you can see the GDPF. That is basically using the forecasted variable as a dependent variable. And so if you remember in the last slide, I think from the lecture, I did indicate that sometimes you can even do it from the logged value. So if you had, for example, if GDP was logged and NPL was logged, so you can estimate that logged function. Once you estimate it, then you click on forecast. So now when you click on forecast, what will happen actually is that it will have ln, for example, ln GDP F. So what you have to do, you just remove that ln. Remember, for example, let me just give an example. When you click on forecast here, instead of it having GDPF, it's going to have, if it was, for example, log, it was going to have, if we are using the logged equation, now it was going to have ln GDPF. So if you just want to um, forecast the actual GDP and not the ln GDP, because you want it to be able, you want to be in a position to be able to compare the R square. If you remember that R square part, it's actually where I'm taking you. So you just remove that ln. Then once you leave it with a GDPF and you click OK, it will automatically put in or leave the GDPF in the what you call it, in the work file. And I'm not even going to what you call it, yeah. So all the other stuff you have to explore. You have to, just like any other computer related stuff, you have to explore with this software if you really want to understand it. So these are just some of the basics. So you can actually now practice all the other questions that are given on the instruction paper. Okay, so this marks the end of these were just the basics, because I'm working on the assumption that you have um, at least used EViews on your undergraduate, and it's actually supposed to be like that. It is supposed to be like that. All right, so this marks the end of this part.